Hello everyone and welcome to this stream. I'm pretty sure the stream is up. So let me just check really quickly. Alright, the stream is up. Perfect. So, as you can judge from the title of this stream, we are going to be making a very simple neural networking library, a neural networking framework, kind of like TensorFlow. So this will be this won't be something that I can do in one stream. This is gonna be something that takes a little bit of time. However, like I hadn't uploaded a video in a while, and about the Jarvis thing that I was talking about in my last stream, I actually ended up coding it off stream because I actually didn't have a lot of time to stream, and so I couldn't exactly get to it on stream, and so I had to do it and I also wasn't able to record it, so that's why. So I'm gonna give you guys the code, so don't worry about that. And so I couldn't exactly get to it All right, so just a second. I'm just gonna kind of quickly check on the stream because I actually have changed up my Mac like display settings, and so I think I might have to tinker a bit with OBS. So I actually don't know if I'll have to do that or not. So yeah. So basically in this stream, that's what we're gonna start to build this, but obviously we're not gonna finish it up because even though we won't be having like a thousands of lines of code like TensorFlow, it still will be a bit of a time consuming process given the fact that we're going to be dealing with a lot of math. And so, yeah, so that's basically what we want to accomplish. Now, if you guys are following along, I hope that you guys are sufficiently, well versed with neural nets. If you are not, then I might, I would suggest that you go ahead and first are so you first understand it. Now the thing is, I had actually started to work on this off stream. However, the code did get really bad, so I think I'm just gonna start writing it right from scratch, because the code was getting a little bad, so I just decided to have a stream for this and do it from scratch. All right, cool. You guys can post anything if you guys want in the chat. Yeah. So if you guys have any questions, I'm open to questions. Also, just write a comment down below. And as you can see, this is a very simple directory structure that I've gone with. Just two files, main file and the testing module file. Now I won't be writing anything like crazy tests and stuff. This is just gonna be me testing out whether the module like library works or not. So yeah, so that's basically what we're gonna be doing. We're gonna start with a dense layer, then we're gonna end up doing activations. We're also gonna be doing loss optimizers, and for all of this I'm gonna be making use of a couple of resources that I have managed to accumulate over time. So I'm just gonna kind of show you which resources I'm gonna be using. So I have a couple of them, but the ones that I'm mainly gonna be using is just gonna be NNFS and this one, mathematics of machine learning. You guys can go ahead check it out. Now in the it's mathematics of machine learning and not neural nets. It actually has a ton of like pure math concepts that are really good, and something that I might want to kind of uh, brief up on. So alright, we do have a couple of viewers now. That's pretty cool. Alright, good. So let's get started. Now we're gonna be using plain NumPy. So that's something cool. And I don't know if we're gonna be needing this right now. You know what? We can just get rid of it. We will import matplotlib if we need it. So alright, so let's get coding. So now there are two ways in which we can approach this. We can approach it in the kind of naive and kind of quick way to do it. I can kind of just code out a dense layer class in here, and I think that's what I'm gonna do right now. And if we end up, the code ends up getting a little lengthy, then we'll kind of tinker with it. So I'm just gonna say dense layer class, and I would also just say np dot random dot seed, and we can just go ahead and like set some random seed. I think I'm just gonna set like 1,000. You can set anything that you want. This is not needed. If you want to have it, then you can have it. If you don't want to have it, it's okay. So yeah, so now we can now for the dense layer we're gonna have a couple of things. We're gonna have a forward pass and a backward pass. uh, so the forward pass is obviously going to be super simple. It's going to be the backward pass that's going to be something that's a little difficult. Now before we even code out the dense layer class, we obviously got to code out another class, which is going to be the weight and bias initialization class. Now we could do it in a couple of ways. We could either just have the weights and biases get initialized when we actually declare the dense layer, or we could actually have a method for that. And I also just realized I also haven't enabled my webcam for this stream, and I think I'm gonna enable it for this stream because I think I could better explain if I have like a webcam. Also, let me just check. Is it not like, because my stream settings, since I've played around with them, let me just check if like my webcam isn't too big or something like that. All right, it's good. Cool. So the way we're gonna do this is something like, I'm basically gonna have a um I'm gonna have like a dense layer class what I just created. So we can have dense, and we can have define forward. So that's gonna be the forward pass, and the forward pass obviously gonna take in the weights, the biases, and we can also take in x. So x is just gonna be the inputs. And okay, you know what, I think I'm gonna have to disable the webcam. I'm so sorry, but that's because my laptop is lagging a bit, so that's why. So I think it should be inputs, weights, biases. Let's just keep the order consistent. So we can just go ahead and say inputs, weights, biases. Now I know a lot of people actually like to start from scratch. They like to actually have like a tensor class, and they actually have like lazy loading and stuff. I really don't want to do that kind of stuff because that's like way complicated, way too complex for me to deal with. And so rather than doing stuff like that, which I seriously have no idea how to implement, I'm just gonna be doing basic stuff. Like I'm gonna have a dense class, I'm gonna have a couple activation functions, a loss function, an optimizer, stuff, standard stuff. So the way we calculate the output is actually super simple. We just do inputs times weights plus the biases. So we can just do np dot dot inputs and weights plus biases, and we can just go ahead and return the output of the neural network, and that's it. I know that this doesn't look much, but that's literally all you need to do for the forward pass. But this obviously doesn't make the cut given the fact that we haven't specified what the weights and the biases are. So now we're gonna have to deal with that. So for that, what I'm gonna do is I'm gonna have like I'm gonna have like a generate weights and biases method. I could either do that, or I could have an initialization for this. If I do this, and if I pass in the weights and actually if I don't do that, if I just have self and I get rid of these parameters, and if I just say weights is equals to np dot random dot random, and actually I think I can't. Yeah, I'm gonna need a couple of parameters. So I'm gonna need the x dimension and the y dimension of the data that we are gonna be loading in. So having that is obviously gonna be a little bit of a problem. So you know what, I'm just gonna kind of put it in a function, because if I do this, it gets a little complicated, but let's try it. Let's try doing it. So if we pass in data, if we just say like dim1 and dim2, so that's gonna be the two dimensions. Now you gotta obviously sync up like these two dimensions to your previous node's output. If you don't know what I'm talking about, it's okay. So here we can just say, and we can just multiply it by 0.01, and then we can just say dim1 and dim2. Obviously we gotta do self dot dim1 and self dot dim2. I think that's correct. I'm very sure that syntax isn't correct, but let's hope it's correct. And for the bias, so alright, so here's how it's gonna be. When you're adding two matrices, now I'm gonna be doing the math on like my whiteboard that I have in front of me. So, and once I have the math done there, I'll kind of show it to you. So if we have an n by n matrix and we are dotting it with a n by p matrix, the output matrix will be of a shape m by p. Now if we are adding it to a matrix of some shape, we gotta figure out the rules for matrix addition. So if we have two matrices, I'm pretty sure you have to have the exact same shape in order to actually add those two matrices up. Now that's gonna be a bit of a problem to figure out. So if we have a m by p matrix, so let's say like 1 2 3 4 5 6 7 8 9, so that's a 3 by 3 matrix. And if you want to add it, let's google it up. I know I can figure it out, but I'm just gonna google it up so I can. So rules for matrix addition of unequal shape matrix addition. Because even though I already know how you can add and subtract matrices, I just want to look at every single one of the rules so that we can kind of, can we have like anything wherein it's not of the same shape? So if we have size or dimension, that and that, square matrix, obviously we know that. Can we have like any other thing? Yeah, see, so this is kind of the thing that we want. Now in this case, obviously you would say that we either transpose B or E if we want to do it normally. Oh, alright, so the answer is going to be undefined. So yeah, we obviously going to have to do E transpose plus B or minus B. Alright, so let's so I already have like a little GitHub repo wherein I was already working on this code, so I'm just gonna put it up because I don't remember how I had kind of done this. Alright, now that's not good. I'm gonna have to sign in. That's not good. Wait a second. Since I don't want you guys to see my credentials to GitHub, I'm just gonna do this. Also, I'm so sorry, like I'm not like constantly working on stuff in this stream. The reason is simply that this is actually a pretty big project, and I kind of want to figure stuff out as I go, and so I am not gonna be doing stuff like that. Alright, there we go. I just signed in, and let me just quickly do that. Alright, good. So here we wanna look at neural network from scratch. So I already had like a simple neural network that I had implemented from scratch. If you guys wanna check this out, this is the link. And we are obviously gonna be making use a ton of code that I had already written for this. So this was like 150 lines of code, nothing too complex. So this is basically trained on the MNIST digit dataset. So the way we initialize the biases or something like this, blah blah blah. So 10 1. Alright, so we gotta make use of the dim1 for the bias initialization. So So when we are initializing the biases, we do 0.01 times np dot random dot rand n self dot dim1 and 1. I hope this works, but not sure. So now what else should we do? Now we have the initialization. So now let's actually test this out. Alright, we can actually test this out right now. So we can just do from main import star, because I don't want to kind of keep on importing stuff. So now we're gonna have to import numpy for this, because we're gonna have to specify the inputs. Now since this is like we can't even call this a neural networking framework right now, we are gonna have like randomly generated inputs. So I'm just gonna have like a inputs. It's gonna be np.random.randn. Now when we're gonna be specifying the inputs, we're gonna have to look at the shape that we provide to the inputs. Now if basically, because if we want to dot the inputs to the weights, we're gonna have to make sure that the column number of the inputs and the weights is the same, otherwise we will end up running into an error, because you cannot do something like that. So yeah, so we're gonna have to figure that out. Now that's actually relatively simple stuff. If you even know like basic high school math, think you should be able to uh, find your way out of the basic linear algebra. Now for like the more complex stuff, I'm gonna be teaching you that along the way, so and even learning along the way. So we have the weights and the biases here, but the first thing that I don't understand, oh yeah, we haven't accessed it, right? Yeah, I gotta set it to that. Alright, now basically what I want to do is, I think I want to do something like self dot weights. I'm not sure. I seriously, I'm not sure with the syntax. I know like I should be, but I don't know. I'm just not familiar. I kind of forgot the syntax for this stuff. Can we do something like this? I'm pretty sure we can, I think, because I'm not really getting any squibbly lines and stuff. So this is going to be np random random, and since the second dimension has to be the same, we can just go 100 by 2, and now let's specify dense 1, and we can just say dense. Now we gotta put in the dim1 dim2, so we can just go ahead and say, so dim1 is obviously gonna be 100. No, wait, dim1 can be anything. Dim2 has to be 2, so we can have 1,000 nodes with 2 classes, and then we can just do dense1 dot forward, and we can just go ahead and have pass in the inputs in this case. So we can go ahead and say inputs, and we can just put it in a variable called output, and we can just go ahead and print out the output. That's pretty good. Alright, that's actually pretty neat. So let me just open up the terminal over here. I'm just gonna be doing it on this terminal, because I don't want to deal with separate terminals and stuff like that. Maybe I think doing this like in a Python file might not be the best idea. Maybe a notebook might be a better idea, but yeah, it's okay. So just do python 3.8 testing module.py. It's gonna take a little bit of time, because I'm kind of running a couple of programs right now, so that's why. But that's kind of what I was doing over here, so I'm pretty sure this should work. I'm pretty sure I haven't made any math errors this time, because the last time I was trying to code this stuff out, okay, I have made a couple of math errors. Shapes aren't aligned. Oh, alright. Oh, okay, that's not exactly an error. I just gonna this has to be 2 and 1000, not 1002. This has to be 2 comma 1000. Oops. Silly error. but it was an error nonetheless. It's okay. I think this should work now. Oh, are you kidding me? Oh yeah, we can't do that, right? Okay. Now see, this is a bit of an issue. What if we just do 200? Like, I'm gonna let me try this out. If we do that, bro, how was I doing that earlier? So it was 10784 and 101, and the training shape had a second dimension of 784. So in my forward pass, I was doing a transpose of the weights. So that basically leaves me with a shape of, alright, so I'm gonna have to copy this code. And yeah, I'm gonna have to open up another terminal window over here. Otherwise it won't work. I really don't want to do this because my laptop is starting to lag, but yeah, I'm gonna have to do it nonetheless. So let me just do IPython 3.8. Are you kidding me? Alright, Python 3.8.5, good. And we can just do import numpy as np, and just do that. Print w1 dot shape. This is what I really wanna have. Alright, so we are doing 10784, obviously. So we have a 10784 in the shape, and for the inputs we're going to be looking at a shape of 10784. So we are doing, so what we are essentially doing over here is we are doing 100. Wait a second, let me, so we have 100 784. We are dotting it with a 10 784, so that gives us a shape of 100 by 10. And then we have a bias term. The bias term had a shape of 10 1. Now since we are transposing it, we are adding it to a shape of 1 by 10, and that doesn't throw you an error. So 110 110, that I think is a valid matrix multiplication. So let's try this out. Let's try it out. So alright, so here what we have is we have a 100 by 2 and a 2 by 100. So that should give you 100 by 100. And since the bias term is based on the dim1, which in this case is 2, it shouldn't work. So I think it should be based on dim2. That's the first thing. And maybe we're gonna have to transpose that, but I'm not sure. So first of all, let's just try running this, and if we do like run into some issue, we'll try to fix that. Oh, okay, we actually don't run into an issue. That is pretty neat. And now I'm actually gonna show you something that you maybe would have expected, but maybe you might have not. So let me show you, because it's something that I find pretty cool. So if we just do so I'm gonna have to import matplotlib for that one. From matplotlib, matplot import plot as plt. And so if I just do a plot on the output, and if we just do a dot r, and if I just do a plot.show, actually no, I can't be doing a dot r on the output. I can just have a r, and if I just do a plot on the inputs, and I'm also gonna have to do one more thing on the inputs, is just do that. And then if we just do a dot b, you should see a pretty cool result. Maybe something extremely expected, or maybe something unexpected. I don't know. You guys can, make your guesses. Unless there's an error. in which case, all right. Now I absolutely did not expect this output. Like I just did not expect this output at all. That doesn't make sense. That output doesn't make sense at all. Because currently we are fitting a y equals mx plus b line. And if that is the output that we are getting, that just doesn't make any sense. That output did not make any sense. You know what? All right, let's do it this way. Let me copy this code. All right, let me copy this code, and let's head on over here. Do that, and now let me copy this code, forward prop code. All right, we're gonna copy this code, and let's kind of see, because according to me, the output that we are getting here isn't expected. Like, I don't think we should be getting that output in this case. So yeah, that's a bit of an issue, but it's okay. Alright, so we're gonna have to kind of initialize this stuff first. So init the params here real quick, and we can then just do forward prop. Just do that, and now let's just. Oh, are you kidding me? Wait, was I specifying that in the forward prop method? Are you kidding me? Oh god damn it, I'm gonna have to copy the forward prop method again. Let's just copy that, paste it here, and let's just kind of modify some of the code here. We don't want to have this, we just want to kind of set it to A1 for now. And obviously we want to set C2 to A2 for now. I know it doesn't make any sense, I could just get rid of them, but yeah, I'm just gonna have that. Alright, so if I were to do that, and if I just do import matplotlib, oops, z2, and we can just do plot.show, and we can then also just do one more thing, plot. We wanna plot. What do we wanna plot now? We wanna plot the inputs, so we wanna plot the x chain, and we're gonna do that. Actually, I think I didn't name it like that. I think I did that. And we also wanna do dot b, and it's gonna take a little bit of time. Are you kidding me? I really don't want to wait, because I don't think that should be the output that we are getting, because it just doesn't make any sense for me. Maybe it is correct, but I'm pretty sure what I'm done is wrong. So alright, that just doesn't make any sense to me. Yeah, we are working with a crazy amount of data in that case, so plotting this stuff doesn't make a lot of sense. So in this graph, as you can see, we do have those alternating lines. That makes sense. Alright, this really is driving me a little nuts. So like, according to the way we have initialized this stuff, that shouldn't be the case. Alright, you know what, I'm gonna crack open like a book now. I'm gonna start doing that. I'm not gonna be able to open up the NNFS copy that I had, because it has my email address, kind of big text, so I can't do that. So I'm just gonna get the from this link. There we go. All right, there we go. Ah, come on, man. Why is it taking so much of time? Also, what is this? Why is it taking me so much of time? Alright, neural networks from scratch in Python. We're gonna be making use of this book, because otherwise there is no way I'm gonna even get through this. Come on, man. I seriously thought I would be able to do this on my own. I won't need anything. What I need is your dense layer class. All I need is that. Just give me your dense layer class. Oh, come on. Just give me your dense layer class. That's all I want. Yep, there it is. Layer dense. So in the initialization, the first thing that I can see is they have written code exactly like me. Oh, alright, now I got it. I messed up the dimensions. That's so stupid. So it was n inputs and n neurons. So you know what? I'm just gonna kind of go with that. So we can just do inputs, shape, and num neurons. Pass this stuff in there. And in here, alright. So if that's the case, then I think we should have like neurons. Yep. Num neurons. And alright, so that's done. And what else? What else do we have to do? Also, why have they set the biases to a bunch of zeros? That doesn't make. Alright, so I think that they are trying to do like zeroed out biases. Makes sense, however, I don't want to do that. So yeah, alright. Let's try this out. So we have kind of sort of the same code. So let's try this out. Let's see if this works. And since they already have a module that allows for quick testing, we can just go ahead and use this, because why not? Let's use that code. So instead of like generating our own like buggy things, we can make use of this. And so we can get rid of, actually we need something. So yeah, alright, so we can create a spiral data set. Now I don't know what the data looks like, so that's gonna take me a second to understand, but that's okay. Yeah, so let's do that. So we can just go ahead and get like the x and print out the x dot shape, because I want to have a look at the data. Also, I'm gonna have to run this like that now. And I'm gonna not stream a lot right now. I'm gonna stop streaming really quickly. But yeah, So it's 300 by 2. Alright, so that's two classes. And then we're gonna have y is gonna be the outputs. So we obviously want the stuff to be acting on x, so we're gonna have two input shapes. So input shapes will be that. So input shapes will be 2. So when we are doing the tens layer, just, oh come on, so we do tens is equals to tens, and we're gonna have number of inputs, so that's gonna be 2, and let's just say 100, and then we can just do tens dot forward, and we can just take an x, store it in the output variable, and let's try and plot out output with a red color, and let's plot out the spiral data in a blue color, and let's show it onto the screen. So if everything is correct, we should have a line of best fit drawn for this output. That is exactly what I wanted. Perfect. So as you can see, we have a line of best fit drawn. Now this data is obviously super basic, and you will see, I hope so, by changing up the number of nodes, number of neurons, we should get like a different result. Yeah, so as you can see, it's a little different, not a lot, but yeah, there is a slight difference. So now we can actually do this, we can do one more thing. So let's say we end up, so now here's what we're gonna do. So let's go ahead and get the shape of the output. All right, let's go ahead and get the shape of the output now. So now we are gonna be doing something cool. We're gonna chaining together a bunch of these tens layers. Now this will be something pretty neat, and something that really make neural nets so cool. So we can now go ahead and chain this. So we can do tens 2 is equals to another tens, and this time we can have, so we have 310 this time. So this is gonna be 10, and we can go like anything, 100. So now if we do output underscore 2 is equals to tens 2 dot forward on the output 1, and then we can go ahead and just plot out the output 2, but this time in green. I want to check the difference between the two outputs, so we can just do output 2, and that's it. Cool. So this should give us a difference between the tens 1 forward and the tens 2 forward. Now since we really aren't doing activations, yeah, there will be barely any difference. As you can see, the difference is minimal. So now let's add one slight change. If we just do output is equals to np dot maximum output and 0, which should be a ReLU activation function, I think we should get a better output too. No, we don't. Now actually we kind of do. We have got a bit of a difference in there, but mainly the reason why we actually aren't getting like a much of a difference is because we aren't really. So I think we could get a better difference if we do something like this, 2 1, and we just do like 10. This should be like something much simpler. Or if we really want to go overkill, we could go ahead and say like 100. I think that should bring up a bit of a difference. Oh, alright, then that and that are not aligned, obviously makes sense. Output tens 1. Oh yeah, I can't exactly play with that, right? Gotta keep that 10. So let's actually get rid of that. So now we have a couple of dense layers. We have two dense layers, obviously. And obviously, right now, while it might not make a lot of sense, we are actually getting into activation functions. So let's actually deal with activation functions. Now you might be saying, where's the backward pass? We'll do backward passes later on. Basically, because it comes later on the book and it's much more difficult. I kind of want to procrastinate it. So let's do activation functions. So let's make ReLU, rectify linear unit. This will be a super simple one. We can just do forward, and we can just take x and x and self, and we can just do return np dot maximum x0. That's it. That is ReLU. Yeah, I know, looks super simple. So now let's do sigmoid. Let's do forward self x, return 1 divided by 1 plus np dot exp minus x, 1 upon 1 plus e to the minus x. Yep, that's correct. And that's it. That's sigmoid. I know I kind of breeze through these two activation functions, but basically the way sigmoid is represented, it's 1 upon 1 plus e to the negative x, and value you can just check the graph out. Pretty simple thing. So now that we have this, let's implement it. So what I'm gonna do here is I'm gonna go ahead and create a sigmoid object. So we can just do sigmoid is equals to sigmoid, and if we go ahead and say sigmoid dot forward on the output, I think that should actually kind of, because activation functions are highly important because they kind of signal when it is that a neuron should fire and not fire. And I think a sigmoid activation function can really kind of be a cool thing. So I don't know, I got rid of the plots. Plot output. Yeah, I actually can't be plotting out the output, right? Because we are already applying a sigmoid on the output. So I want to do output s when I apply the sigmoid. So I want to do output s, so that's sigmoid, and then we obviously want to do it on the output s. So we can do output. We also want to plot out the output 2. We don't want the output s, that doesn't really make sense. So you can do r g, and then we can have the x. So that's gonna be the inputs, and that's gonna be b. Alright, if I can get this thing done right now, I might just end the stream. Where is the graph? Oh yeah, I didn't do plot.show. Okay. Where's R and G? I can own. Where's R? Where is R? Alright, so let's do it in this way. Let's do that. And let's do that. Actually, just do that. Alright, cool. Let's do it in two separate graphs. Alright. So as you can see, by applying the sigmoid and then doing that, it actually led to a difference. Pretty neat, right? So as you can see, that is the difference between the output 2 and the output 1. The more layers that we add. So if I, this should be too much, but I can have, I'm having fun experimenting. So let's try doing that. It will take a hell of a lot of time to compute this stuff, but let's try this out. It actually did not take a long time. So as you can see, this time the output's changing from like 0.25 to -25, but that's okay. And as you can see in this way, it's much more kind of localized to 0. So yeah, that's pretty neat. Alright, cool. So now that we have this, we can actually code out another activation function. We can also code out softmax. Softmax is another activation function. It is relatively complicated to find the derivative of the softmax activation function. So I did not want to have this, but it is extremely important activation function because it returns a set of probabilities given a set of inputs. And if you know anything about neural nets, you kind of should be knowing that they really do rely on probabilities. And so I have to code out the softmax activation function. I'm basically going to be looking at some code to find that derivative. I'm not going to be doing it by myself. I will do sigmoid by myself and I'll do tanh by myself. Those two things I can actually compute derivatives of. I'm pretty sure. I'll try my best. So we have softmax. Softmax is, I actually don't remember the equation for the softmax activation function. Softmax activation function equation. I just want to know the equation, that's all I care about. It's easy I np dot sum easy. Okay, this is simple. np dot exp e divided by np dot sum. Is it np dot sum or is it just sum? Can we have sum e np dot exp? Oh, that's not e, that's gonna be x. Oops. Is it np dot sum? Let's do np dot sum. I actually don't know what it is, so let's do np dot sum. Cool. So now what we can do is we can do output 2 is equals to we can go ahead and do softmax is equals to softmax, and we can just pass it in here, softmax dot forward on the output 2. That's it. Cool. That should be it, I'm pretty sure. Hopefully my softmax activation function code is correct. Otherwise, it won't be that great. But yeah. So as you can see now, initially we had such a big range of probabilities. But as soon as I applied the softmax activation function, it just collapsed into this one line. And that's the beauty of the softmax activation function. So there was a bit of uncertainty, but we calculated the probabilities and then we just collapsed. That's pretty neat. So that's the reason why I was talking about adding a softmax activation function and why we cannot ignore adding a softmax activation function. So as you can see, I kind of breezed through the 3 activation functions super quick, and to be honest, I can actually code out the derivatives also relatively quickly. So if we do want to add a backward pass, because this is just quotient rule, this is pretty simple calculus. This is also super simple calculus. This is something relatively difficult, actually pretty difficult. I have no idea how to do it, and so we're gonna be looking at an article, because since I can't figure it out, I'm gonna have to rely on other smart people, much smarter than me, obviously. But yeah, activation functions, and we can just do layers, because I am planning to add a convolutional layer to this. I don't know, no promises, but yeah, because I do have a couple of cool blog posts that do go over that. So yeah, that's it for this video. I hope you enjoyed the video. If you did, I'm sorry, stream. If you did, like, subscribe, comment down below what else it is that you guys want to see. I obviously there's not a lot of action going on in the live chat. Oh, all right. Damn. Go study chemistry. I know. I was studying chemistry before this, so yeah. I actually have my exams going on, so that's the reason I hadn't uploaded. Cheers, man. Cheers. Hey, man. That's my friend. Uh, I think I should be kind and polite. So I'm gonna reply to each one of you because I don't get a lot of people in my chat. Hey, hey, man. I'm not gonna like since. Hey, man. Hello, and thank you for staying at this, time to chat. I'll go to sleep. That's my brother. He's obviously gonna be mean in the comments, but I don't care. It's okay. Big fan, sir. Go study chemistry. Yeah, you gotta help me out with that. All right. So that's it for the stream. Uh, if you guys enjoyed it, comment down below. If you guys want to have any suggestions, if I did anything wrong, which is highly probable, uh, you know let me know. I'll surely incorporate that stuff. So yeah, and I'm so sorry I didn't upload for like a month. But I seriously, there was just no way I was gonna be able to get to videos. I barely had any time to code stuff out myself, let alone explain it to you guys. And so while I was able to get a couple of projects down, they really weren't that much. And so I just decided to not make any videos, and I'll be back to my regular uploads super soon. Basically, I have like my exams ending on Monday, and so I'll get to uploads from Monday. So if you guys wanna check out any, so my next video is, I'm pretty sure it's gonna be on Monday, Tuesday, something like that. So that's it for this video. I hope you enjoyed it. If you did, like, subscribe, and until the next time I see you guys, bye bye.